We can see that crawl spaces, it's oftentimes they're damp locations. That's why code requires we have plastic over the crawl spaces, but also it's important that that insulation be installed correctly. Here's an example where it is not. The crawl space is falling down, the vapor retarder is on the wrong side of the insulation. Here we can see that the insulation is not even in contact with the bottom of the subfloor, so that would be a faulty insulation that would fail code inspection. This is a much better approach where we actually have the insulation that's almost filling the cavity and it's in complete contact with the bottom of the subfloor. Now, basement walls, there are some requirements around that as well. Also, for basement walls, it's important to know that in climate zone 4 is that an R10 continuous insulation or R13 in the cavity insulation is required on the basement walls. Now, that only is required to go down to the frost line. That's different from the 2009 IECC. Now, here's another important thing to note with regards to basements. When you're looking at basements, sometimes it's kind of hard to figure out, particularly in walkout basements, whether it's in a basement wall or it's an exterior wall. So, for example, if 50% or more of the basement wall is above grade, you would follow the prescriptive requirements or insulation requirements for above grade walls. If 50% or more is below grade, then you would follow the requirements for below grade walls. So here, for example, we can see how we might take some different approaches to insulating basements. This is where we have a cavity wall system where we actually put studs up and fill that with fiberglass insulation. Another approach, as we see here, is to put foam on the exterior of the basement wall, and you'll notice that they're putting a coating over the top above grade so that insects and ultraviolet light doesn't affect the longevity of the rigid insulation. But you could put insulation also in the interior of those walls as well. Now let's take a look at slab edge insulation. We require R10 in Kentucky. That's typically 2 inches of extruded polystyrene at R5 per inch. So that's for climate zone 4. Now that insulation's got to go downward from the top of the slab a minimum of 24 inches. Now the insulation can be vertical or extend horizontally under the slab or out from the building, but must be under 10 inches of soil. So, for example, if you're going out from the edge of the building. So, for example, the first example we see here is exterior insulation, much like the slide we showed earlier, and we have some protection board over the externally applied rigid insulation. The middle example, figure 3, is where we see rigid insulation that runs 2 feet down from the edge of the slab, and then the third example is of a horizontal installation where we see insulation at the edge of the slab and then insulation go horizontally 24 inches towards the interior of the building to reduce heat loss.
Kentucky also has alternate ways of insulating this. Here is the detail for a garage, drop brick, siding or paver, and siding. The alternate methods of insulating can be found in Chapter 11 of the 2013 KRC. This is located at www.dhbc.ky.gov.
Now, there is a provision in the code that does allow you to taper the insulation like shown in this picture. And the reason for that is that if you're attaching hardwood flooring or something to the slab, you might have 2 inches of foam on the edge of the slab and not have a nailing surface. So they allow you to chamfer that insulation so that the concrete can go all the way almost to the edge for proper application of flooring materials. Now, this is an example of a thermographic image of where we see a lot of heat loss at that slab area. And this is why it's important that we insulate the edge of the slab to reduce this heat loss in this location. Another option in the code is to insulate the walls of crawl spaces. In crawl space wall insulation, the practice basically eliminates the need for insulation for the raised floor above the crawl space, and it's kind of treated like a basement. So the crawl space cannot have ventilation or openings to the outside, but it must be mechanically ventilated, at least 1 CFM per 50 square feet, and the crawl floor must be covered with an approved vapor barrier material. A lot of moisture comes up from slabs, and so if we have a conditioned crawl space, or even a semi-conditioned crawl space, we don't want that moisture in there. All right, so basically this is covered in the code under section 402.2.9.
Conditioned crawl spaces have several advantages over traditional ventilated crawl spaces. Number 1, a properly sealed, Moisture-protected and insulated crawl space will increase comfort and save energy. Number 2, the opportunity for moisture damage due to condensation from warm, humid air entering through the vents and condensing on cold building components such as floor joists or the floor system is greatly reduced. Number 3, they are less likely to harbor pests. When the crawl space walls are insulated, the foundation vents are prohibited. The space should be mechanically ventilated, as I mentioned, or conditioned.
And it's basically the requirements are like a basement. So that means you have to have R10 continuous insulation or R13 cavity insulation. Now this is a pretty good example of a nicely insulated crawl space wall assembly. Also important not to forget the band joist areas. Here's an example of how spray foam, in this case closed cell spray foam, completely fills those voids and does a good job of air sealing. This is particularly helpful in crawl spaces. The issue behind vented and non-vented crawl spaces, there's a lot of controversy over that, but the reason why we ventilated crawl spaces in the past is because we typically didn't put plastic down. And of course the concept was that we had to get rid of that moisture. Also, if we had a lot of water that got down in the crawl space, that was certainly very challenging to get rid of without vents. In a non-vented crawl space, we take a slightly different approach. The concept is to make sure that the crawl space is completely dry. And that means we have adequate drainage, we have around the perimeter, we have opportunities to drain water that might get into the crawl space, we also have adequate vapor retarders, and we have a ventilation system. And so with the crawl space not being vented like that, the space is really treated almost like a semi-conditioned space and can't even be conditioned, treated almost like a basement. Now it's also important that we recognize that when we do crawl space wall insulation, that in heavy termite infestation areas, we want to leave an inspection strip. And that is so that we see any activity, any termites that might have burrowed back underneath the foam and worked its way up, or cavity insulation, worked its way up behind that foam into the framing system. So this inspection strip allows us homeowners to do periodic inspections to make sure that they don't have any termite infestation. Okay, now let's move to sunrooms. Basically, sunroom requirements, and this is in section 402.3.5, has a ceiling insulation requirement here in Kentucky of R19. And the fenestration maximum U factor for this climate zone 4 is a 0.5 or less. The wall insulation needs to be R13, and the maximum U factor for the skylight is 0.75. These are requirements for sunrooms. Now, it's also important to recognize that we can have less stringent insulation R value and glazing requirements if the glazing area is less than 40% of the gross exterior wall and roof area. Also, we have to have a separate heating or cooling system for the zone and must be thermally isolated with closable doors or windows from the rest of the house. So in other words, it can't have open areas into the house. It has to be isolated from the rest of the house in order to qualify for the less stringent insulation, R value, and glazing U factor requirements.